Hello, everybody. Here we are, 4.3 continued rational exponents. Rational being a kind of fancy way to say decimals or fractions. And what I want for the notes today, or what I want you to think about for this section, is you should memorize the most common perfect squares and perfect cubes. So for our perfect squares, we got, remember, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on and so on and so on. 121, 144. Good to memorize up to 15 times 15. And for our perfect cubes, at least just 1, 8, 27, 64, and 125. So at least the first 5. And these are really helpful. You'll start to see that these numbers come up quite a bit in all the questions that we're dealing with. And they can be a little hint at something that you need to do. So I would say at this point you should memorize, you should know these perfect squares, and you should know these perfect cubes. If you don't, try to start to commit those to memory. Okay. So let's go. I think this part of the notes will be a little bit more apparent in question number 3. No, I skipped 2, but let's keep this in mind for when we get there. So state the answer using positive exponents. Here we have the same base. They're being multiplied, so we can add the exponents. We can go y to the -2. And I would personally, I think the thing that I find interesting about Math 10 is that you have some options. You can kind of choose your own adventure. And I would personally like to convert this to a decimal. You can do that by going 5 divided by 2. But I know that 2 can go into 5 twice without going over. So y to the power of 2 point, there's 1 left over, so it makes a half. So 2.5. So you could do that in your calculator if you'd like, if you're not super fast at it or you're not used to seeing it. 5 divided by 2, 2.5. And now we have the same base, and we can add the exponents. Y to the power of -2 plus 2.5. And -2 plus 2.5, so it gives us y to the 0.5, or y to the half. Very good. This next one, remember that this is like a -8 times an x to the 6. So when we distribute this inside, we need to multiply this third by the -6, and we need to multiply it by the -8. And I guess I would first want to deal inside the brackets. We don't really want a negative exponent. So what do? That means we can make that, we can make it kind of go upstairs, downstairs, as I call it. -8 over, this goes to the bottom, becomes x to the positive 6, or essentially what we're saying, this is 8 to the 1 times 1 over x to the positive 6, remember? And then when I combine them, they become -8 over x to the 6, and this whole thing is still to the power of 1 over 3. So let's show that. -8 over x to the 6. And this is all to the power of 1 over 3. And now we can distribute this inside. So the 1 over 3 can become -8 to the power of 1 over 3. And this 1 over 3 can multiply with the 6 as well. Let's show that. -8 to the 1 over 3 over x to the 6 times 1 over 3. And now there's kind of 2 things that I'd like us to remember that we can do. So this one, I'm going to convert it to a radical. So I want to have this, remember, on the bottom becomes the root. It's on the bottom of the roots, just like a tree. So we can go 3 -8 over. And here, I wouldn't bother with what I just did there. I would just multiply these 2 together. So 6 times 1/3. You can multiply the tops. Remember, this this is like a 6 over 1. We can multiply the tops. 6 times 1 is 6, over 1 times 3 is 3. And our last step, the cubed root of -8, what times itself 3 times gives us -8? That'd be a -2 over x. 6 divided by 3 is 2. So there's our final answer for that one. Yeah, here's our final answer there. Let's do this next one. Here's, I think, a good example of, that you can, I would start by multiplying this inside. So let's do that. A half times a third and a fifth times 2/5. So on the top, I've got green. We have x to the power of 3 times 1 over 2 and x to the power of 5 over 2 times 1 over 5. And now let's see. Remember, this is over an invisible little 1. And let's multiply. We got x over 3 times 1 is 3, over 1 times 2 is 2, over, you could cross reduce here. Cross reduce is when you look diagonally before a multiplication question and reduce. So 5 can go into 5 once, 5 can go into 5 once. You're left with x over 1 times 1 is 1, and 2 times 1 is 2. And now we can subtract. We have x 3 over 2, subtract 1 over 2. Nice and tidy. 3 subtract 1 is going to be x 2 over 2, or just x to the 1. There you have it. Okay, this next one, I was about to say this is a good example of you can reduce first, but I think this is a better example. I actually think that's a very good example. This one is better. You could, if you want, deal with this first, or distribute inside. So maybe we could start there. I don't know. I might honestly prefer to distribute inside first and then deal with that after. So yeah, you could go x to the quarter, subtract x to 3 over 4. But I think I'm going to multiply inside first, to there, and to there. So let's go. We have on the top x 1 over 4 times 1 over 2 over, we'll have 16 to the half times x to the 3/4 times 1/2. Let's see what we get. We get x to the 1 over 8. So 1 times 1 is 1. 4 times 2 is 8. Over 16 to the half. If you recall, we can put the 2 in the root spot in 16. So we're looking for the square root of 16, which we can convert later to 4. And here we have x to the power of 3 times 1, which is 3, over 4 times 2, which is 8. Okay, and now let's simplify what we can. We have an x. I'm going to give us a little bit of space up here just to show you this step. We have an x to the 1/8. Subtract, it's being divided by this one right here. Subtract 3/8. It's the same number on the bottom, which is helpful, but it's going to end up being a negative. So we're going to end up with x to the -2 over 8, or x to the -1 over 4. So we'll end up, let's say, our x to the -1 over 4 over, this is the next part that I'm simplifying right here, the square root of 16. So what times itself equals 16? I know that to be 4. And let's do a kind of final step. We don't want a negative exponent, so let's move this to the bottom and convert our negative exponent to a positive. So we end up with 1 over 4 and x to the quarter. Oh, quarter, not a 2. Okay, let's do this next one. I hope you will all remember that anything to the power of 0 is just 1. So that's dealt with. Let's do this next part. Now we can just distribute this inside. 6 times a third. So x to the power of a third times 6 over 1. That equals x to the power of 1 times 6 is 6, over 3 times 1 is 3, and 6 divided by 3 gives us x to the 2. Okay, so sometimes a lot of steps, just take it slowly, take it methodically, remember your rules and apply them, and you might, kind of apply a different method to a different situation, but as long as you know all the methods, you should be fine. Let's do number 3 or 2, I guess, depends what you want to call it. And here is where I think it's very important for us to know the, certain number of perfect squares and of perfect cubes. Because converting this to a 5 or a power with the base 5 can really help us solve this without using a calculator. So let's do it. We have 5 to the negative 2. Let's leave that. But let's convert 125 to a power with base 5. So I can rewrite 5 as 5 cubed. That is equivalent. It just looks different. And now that's to the third. So now we can go, we got 5 to the negative 2 over what's 3 times 1/3. Remember, there's like a little invisible over 1 there. And we're going 5 to the 3 over 3. I just did 3 times 1 and 1 times 3. So we got 5 to the negative 2 over 5. 3 divided by 3 is 1. And now we have 5 to the negative 2, subtract 1. I'll show you that step. 5 to the negative 2, subtract 1. So we have 5 to the negative 3, or 1 over 5 to the 3, or I got some room here, 1 over 125. That's our final answer. Okay, and it could have been much more difficult if we didn't convert this. I mean, we could have used the method, I suppose, where we go 3, 125, and you could recognize that as being just 5. Maybe that would have been simpler, but I think this is a good skill for us to practice. Okay, here, what is a way that we can rewrite 9 and that we could rewrite 27 as a power with the same base? Well, I know we can rewrite them as a power with the base 3. So we can rewrite this as 3 squared to 3 over 2 over 27 is 3 cubed to the 2. And then we can distribute inside and solve from there. So let's distribute. This becomes 3 to the power of, this is over a little invisible 1. Let's not forget. And 2 times 3 is 6 over 1 times 2 is 2 over 3 to the 6. Now we've got 6 divided by 2 is 3 over 3 to the 6. Now we have the same base. They're being divided, so we can subtract. 3 subtract 6 gives us 3 to the negative 3. Negative 3 equals 1 over 3 to the positive 3 equals 1 over 3 times 3 times 3 is 27. Okay, so you kind of get the idea. We're going to keep on looking as ways to rewrite our numbers as powers with the same base. So I guess this is memorizing more than perfect squares. It's also kind of remembering what are our kind of like main powers. So I know that I can rewrite 8 and 16 as powers with base 2. So I can rewrite this as 2 cubed, that's 8 to the power of 2 over 3, times 2 to the power of 4 is 16, 3 over 2. And now I can distribute this inside. And now this, makes it possible to solve these without the calculator. This equals, hello everybody. I think I got cut off around here. I had it on mute, so I didn't even hear where I got cut off. But anyways, I think I was saying that this makes it easier for you to solve without a calculator. And now we can distribute inside. And what I wanted to show you, what I did show you before, is that there's a little 1 over each of these, and we can multiply inside. We get 2 to the power of 3 times 2 is 6 on the top, over 1 times 3 is 3, times 2 to the power 4 times 3 is 12, over 1 times 2 is 2. That equals 2 to the power of 6 divided by 3 is 2, times 12 divided by 2 is 6. And now we can add these exponents. We get 2 to the power of 8, and I need to use my calculator. 2 to the power of 8, 256. Okay. It did ask me, I think, to solve without my calculator, but, maybe simplify without my calculator, sure. Let's do this next one. This one we don't have to rewrite any bases or anything like that, and let's just distribute inside. We have 3 to the power of -2 times -5 over 2. And remember, there's a little over 1 right there. And now we can just multiply. 3 to the power of -2 times -5 gives us a positive 10 over 1 times 2 is 2, which gives us 3 to the power of 5. Let's do that in my calculator. 3 to the power of 5, 243. And our last one, you could distribute this inside. I want to deal with this. When I see this 1/3, I'm drawn to the idea of root, and I know that 5 cubed is 125. So I would like to show this as 5 to the power of 3 to the -1/3. And this whole thing is still squared. And now let's deal inside. We have 5 to the power. Remember, this is over a little invisible 1. We're going to end up with 5 to the power of -3 over 3. And this is still squared. So that's 5 to the power of -1 squared. And that gives us 5 to the power of -2. That's 2 times -1. And this, as you recall, is the same as 1 to the power, or 1 over the power of, 1 over 5 squared. Wow. 1 over 5 to the power of 2. And this equals 1 over 25. So there you have it. A few ways to solve these things, and a few ways, I think, especially that you can figure it out without your calculator, that I encourage you to do. I think it's really good to know the ways in which you can kind of manipulate these things, and the different ways that you can approach them. So thank you so much. I think we'll just continue on with the textbook work.